Mawa, hey, we're going to take a look at a couple articles. First, a new theorem predicts that stationary black holes must have at least one light ring. Here's the illustration of a black hole surrounded by a light ring and by an accretion disk. The image of a black hole obtained with simulations is shown near the lower right corner. The article says the LIGO-Virgo collaboration was able to detect gravitational waves around these celestial objects using some of the most advanced gravitational wave detectors in the world. Meanwhile, the Event Horizon Telescope Research Group captured the very first image of a black hole shadow. While both these observations are highly promising and captivating, neither of them is likely to unveil the event horizon, the boundary defining the specific region in space around a black hole from which nothing can escape. Nonetheless, they should contain a signature pointing to a neighboring region just outside the event horizon, wherein light is bent so strongly that its path closes over itself and forms circular orbits known as light rings. Researchers at the Max Planck Institute for Gravitational Physics in Germany and Universidade de Aveiro in Portugal have recently introduced a theorem that makes predictions about light rings around stationary black holes. Their theorem, presented a paper published in Physical Review Letters, suggests that equilibrium black holes must, as a general rule, have at least one light ring in each of their sense of rotation. Quote, remarkably, the properties of light rings can encode much relevant black hole information, Pedro Cunha and Carlos Herdero, the two researchers who carried out the study, told phys.org via email. Measuring these properties grants a direct window into the elusive and yet fairly uncharted regime of very strong gravity close to a black hole. At this moment, it is still unclear whether Einstein's theory of general relativity remains a good description of the laws of gravity under such extreme conditions. Quote, in other words, we do not assume that one law of gravity is correct, but only assume that the correct law of gravity, whichever that is, allows the existence of black holes, Cunha and Herdero said. Quote, then forcing the space-time structure to obey some regularity requirements, the existence of a black hole implies that there must be a light ring outside the horizon. So the black holes have rings? Okay, let's take a look at the next article. Black holes, they are like a hologram. The article says, according to new research by CISA, ICTP, and INFN, black holes could be like holograms, in which all the information to produce a three-dimensional image is encoded into a two-dimensional surface. As affirmed by quantum theories, black holes could be incredibly complex and concentrate an enormous amount of information in 2 dimensions, like the largest hard disks that exist in nature. This idea aligns with Einstein's theory of relativity, which describes black holes as three-dimensional, simple, spherical, and smooth, as depicted in the first ever image of a black hole that circulated in 2019. In short, black holes appear to be three-dimensional, just like holograms. For scientists, black holes pose formidable theoretical challenges for many reasons. They are, for example, excellent representations of the great difficulties of theoretical physics in uniting the principles of Einstein's general theory of relativity with those of the quantum physics of gravity. According to relativity, black holes are simple bodies without information. According to quantum physics, as claimed by Jacob Bekenstein and Stephen Hawking, they are the most complex existing systems because they are characterized by enormous entropy. To study black holes, the two authors of the new study, Francesco Bernini and Paolo Milan, used a 30-year-old idea called the holographic principle. The researchers write, quote, this revolutionary and somewhat counterintuitive principle proposes that the behavior of gravity in a given region of space can alternatively be described in terms of a different system, which lives only along the edge of that region and therefore in one less dimension. And more importantly, in this alternative description, called holographic, gravity does not appear explicitly. In other words, the holographic principle allows us to describe gravity using a language that does not contain gravity. What Bonini and Milan have done is applied the theory of the holographic principle to black holes. In this way, their mysterious thermodynamic properties have become more understandable, focusing on predicting that these bodies have a great entropy and observing them in terms of quantum mechanics. You can describe them just like a hologram. They have 2 dimensions in which gravity disappears, but they reproduce an object in 3 dimensions. So they're saying that this black hole has an accretion disk that's 2-dimensional, and that the black hole itself has it encodes information on its 2-dimensional disk and then uses that to do 3-dimensional things. Is that actually what it said? Might have to reread to be sure, but so it sounds like the Holy Grail, where the Aurora Borealis projects up to the stars, like the ring would be like the opening on the center of the map, where there's these 4 islands that make an X. So every compass points to the Holy Grail. To get to the Holy Grail, you need to upload your blood over intent to the Ethernet on YouTube. Writing, "I intend to bring forth heaven on earth," recording yourself, putting your blood on the paper, and uploading the video to YouTube with the title Blood Over Intent, the tag Blood Over Intent, and the description Blood Over Intent. Okay, thanks for watching. Let me know if you have any questions. Arigato, matane.